Right, so this is Geometry Section 8.4, Trig Ratios Part 2. We're going to be continuing on with the notes, and we'll be talking about how the trig functions relate to your special triangles, the 30, 60, 90, and the 45, 45, 90. So if you're following along in the notes, we're just going to head to the next portion from where this last video stopped. So it should look something like this. Right, there's two triangles in your notes, a 30, 60, 90, and a 45, 45, 90. And on those special triangles, we already have listed the relationships that we developed in the second section of this chapter, that for the 45, 45, 90, you have two legs, right, which are the same. And if you take that leg and multiply it by √2, that will give you the hypotenuse. We also have our 30, 60, 90. Across from the 30 is our short leg, which we called x. If you double that, that's the hypotenuse, and if you multiply it by √3, that's the long leg across from your 60-degree angle. So now if we look at our trig functions, right, sine, cosine, and tangent, specifically for these triangles, if we look at sine of A in our 45, 45, 90, so we come up here to angle A. Sine is, of course, opposite over hypotenuse. So that would give us x over x √2. Right, whenever we have something both on top and bottom, in the numerator and denominator, we can cross them out. So our x's will reduce, and I'll just have 1 over √2. Well, I know I can't leave a square root in the denominator, so I'm going to rationalize it by multiplying it by a value of 1, which is just √2 over √2. And then on top, I have 1 times √2, which is √2. √2 times √2 on the bottom, which is √4, which is just 2. So sine of 45 degrees, well, no matter the size of the triangle, will always be √2 over 2. It will always have that same relationship. If I go to angle C down here and take sine, it's opposite over hypotenuse because it's a 45, 45, 90. Right, it has that same relationship, so everything would happen the same, and I'd get √2 over 2 as well. So sine of both of these angles would be the same, right, because the opposite sides from both are the same. They're both x, so I get √2 over 2 for both. For cosine of 45 up here at angle A is adjacent over hypotenuse. So that's going to be x over x √2, and once again, the same thing would happen. The x's would cross out, I'd rationalize, I get √2 over 2. Same thing down here, adjacent over hypotenuse, x over x √2, which would simplify to √2 over 2. The 45, 45, 90 is nice because sine and cosine work out the same. In tangent is opposite over adjacent, and that would be x over x. Anything divided by itself is just 1. And then tangent of C, opposite over adjacent, same thing. It'd be x over x, which is just 1. Right, so for sine and cosine of either angle, we get √2 over 2. And for tangent of either angle, we just get 1, which is kind of nice. And the 30, 60, 90, we have sine of A. So sine of A is opposite over hypotenuse. So that's x over 2x. Well, x over 2x, the x's cross out. Sine of that 30-degree angle is 1/2. So sine of 30 is 1/2. That will always be true. If I look at angle C, sine of this would be opposite over hypotenuse. So x √3 over 2x. The x's will cross out. And I get √3 over 2. So you'll notice because your legs are different, if you flip the angle that you're looking at from angle A to angle C, right, those values do change, 1/2 and √3 over 2. Now, if I look at cosine of angle A, cosine is adjacent over hypotenuse, x √3 over 2x, which reduces to √3 over 2. You'll notice that sine of one angle is equal to cosine of the other angle, which is kind of a neat property, right? And you can assume that sine of one angle is equal to cosine of the other, which we'll see here. If you look at angle C, cosine is adjacent over hypotenuse, x over 2x, which would reduce down to just 1/2. If I look at tangent of 30, be opposite over adjacent. x over x root 3, which is 1 over root 3, which I can't have. So I'll rationalize root 3 over root 3, which gives me root 3 over 3. Just the opposite, if I come down here to angle C, I would have x root 3 over x, which is just root 3. Right? So these are reciprocals, as well as these are reciprocals. Right? And then sine of one angle is equal to cosine of the other angle. It just so happens in our 45, 45, 90 that sine of both angles are the same and sine or cosine of both angles are the same. So when you see a 45, 45, 90 or 30, 60, 90, these relationships will always hold true. Therefore, these sine, cosine, and tangent values will also always hold true. You'll notice that the actual scale factor, right, these x's, doesn't matter because they will cross out, right? So it doesn't matter the size of the triangle. As long as it has these angles, these relationships will always be true. Remember, trig functions are just relationships between two sides of a triangle. So those will always hold true. Down below in your notes, you have two examples, word problems, right, about building ramps. They don't give you a triangle. So you need to draw a right triangle first, label all the pieces that they give you, and then go ahead and go through and solve the problem that they're asking. So that's it for this video. We'll pick up the next video with inverse trig functions. If you'd like to subscribe, like, and leave a comment if you have a question. We'll see you for inverse trig videos in the next video.